At the very basic level, a game entity is anything with a position and a method for updating it. Updating the state of the entity, not so much the position. Because not all entities need to move. In fact, not all entities need to render themselves either. Not all entities need to participate in collision detection. So the base entity needs very few properties, and if you wanted to make an abstract interface for the entity hierarchy, you could make it with just 3 members. You would have an X position, a Y position, and the void update method. However, I like a little bit more convenience out of the base class, at least in the beginning of a game project, which I can then refactor out into a proper hierarchy as I discover what the game design requires of me. For now, though, I've chosen to share with you my boilerplate for the abstract entity class. So if you scroll down on the course website, go to the base entity class. I have an article here that basically covers why I choose to implement this class the way I do. At the base of it is the entire source code intact, so I'm just going to copy that over and encourage you to go read this article for the details. I might go over a few of it in this video. So I create a new class, I call it entity. I make sure that it's abstract because I never want a pure entity. And then I paste my code. I'm going to move the destroy method up. And destroy is basically just a stand-in for the destructor we have in C++. I just need a way to reclaim memory. So if an entity has acquired a bitmap, for example, when I load a new level, I need to dump all my entities and make sure that that memory is reclaimed instantaneously. I can't wait for the garbage collector to come around when it feels like it. That can affect our frame rates. And so what I do instead is I let every object that might acquire a resource have a destroy callback. And then as I need to load the level, or if resolution changes and I have to resample all bitmaps or whatever, I can destroy everything on my timetable and then recreate them without running out of memory. So, as you can see, I have my X and Y position, but I also have width and height and velocity in this base class. Not all entities need to move, so not all entities will need velocity. Not all entities need to draw themselves or participate in collision detection, so they don't need width and height. Still, they are in here. When I know what I need from the engine, I will start splitting these up. If I have a ton of background items that don't need collision detection, I might remove these and create, a purer entity and then create something like a background entity or a static entity versus a dynamic entity, whatever. For now, let's just roll with this because it makes it convenient for us to create our first couple of entities to see what this is all about. Another question mark here is this static member. A static member belongs to the class, not the instances. And in this case, it's just a reference to the game class. It allows us to access shared resources like the context when we need to load bitmaps, or to ask questions about the game state. If an entity needs to know how fast the player is moving, or if a button on the controller is pressed, we need to access it somehow, and reaching through the game class to get at it is easy. We can absolutely refactor this later, but the quick and dirty way works for quite a while. It works for more than you'd think. What's important here, of course, is that this can never be null. If an entity has been created, this should never be null. So the first thing we have to do after creating this class is basically go to game and make sure that that reference is set. This is my game class. This is the constructor. The first thing I'm going to do is bring an entity and set game to this. Similarly, at the end of game, there should be a destroy function where I have to set it back to null. This is crucial because Android and the garbage collector, and particularly the activity lifecycle, is sensitive about references in static storage. So make sure you overwrite this value at the end of your application. All right, so we have an entity. We need something practical to do with it. Read the article for the rest of these details, but what I should mention is I leave these accessible to the rest of my code, so I don't need to use setx, getx, setWidth, getWidth as function calls. I can read and write them directly from the rest of the code, which makes it way more convenient for us, and presumably slightly better performance. I do have convenience accessors though, for when I need to do some basic math with this stuff, and also to make the code using them slightly more expressive. Every now and then, you want to know where the left side of an object is, or the right side of an object is, the extremes, the bounding box, if you will. And those values are important in many places, but not least in collision detection. So right now, there's a very simple axis-aligned bounding box test at the bottom here. You can draw these out on a paper to see how the logic works, or follow this handy link where there's a great discussion on overlap tests of different kinds. But in this case, yeah, if two items occupy the same space on screen, they are colliding, we should do something with it. So there is an isColliding function that the engine can call with another entity. It runs this test, which does its work, and if there is a collision, the engine will notify the entity by calling on collision with the entity we are colliding with at the moment. That's basically it. Update will update our game state, and render will let us draw ourselves. That's not always the case. Like, not all entities... Let me put it this way. Not all engines let entities draw themselves. Particularly if you move into, say, multi-threaded engines, you might want to have a completely separate renderer, which you give render tasks, so it doesn't know about entities at all. And that's fair. But letting the entity do its own drawing means we can let our entities do very, very different things. So our player entity will use bitmaps, but maybe our background stars will draw themselves using the drawing API, which we can demonstrate now. Because now that we have an entity, let's create one concrete one. So create a new Java class, call it star, superclass is entity. Make sure you pick your entity from the Space Shooter project and not anything else from the Android API. So this is a concrete class. It needs a constructor. Not gonna take any arguments right now, because I don't want the game to have to deal with, say, positioning or anything else really in this regard. I'm gonna let it pick a random position and random velocity and everything else for now. And then later on, if we need to change, we can change. I want to override a couple of methods. So Alt Insert to get the generate tooltip. Go to override and then bring in update and render, because those are the things I care about. In update, the thing you kind of always want to do for an entity is basically add your velocity to your position. Integration. Obviously that's not a plus, that's an equals. This means that now this entity can move, basically, right? In render, what you want to do is draw yourself, and in this case, the circle. Let's say I want to do... First, I need to set the color I want to draw with. I should probably make that a member. It's an integer, so we can use hex codes for this. So I'm going to start out with, let's make that private. Hex code, you start out like that, and then probably do FF for full alpha. That is 255, which means it's opaque. I don't want transparency. And then you have the red, green, and blue channels. So, I don't know. Something like that. Red, green, blue. We'll see whatever that turns out to be. I'm not super invested in it right now. So we start with setting the color, then we ask the canvas to draw for us. We can draw bitmaps, you can draw texts, we can draw lines and circles and rectangles and all kinds of stuff. We can start with rectangle. So let's draw a rect. That takes 4 values. So it takes X and Y position. It takes, oh my god, it takes the right and bottom. So that will be, actually we have those, so we can do this. And then lastly, it will have a paint object. All right. A square is not a good substitute for a circle, but it will let us play with another thing when we come to world wrapping. So for our star, I want to set x and y to a random value. I don't want each star to create the random generator. So let's add that to the game, because we have a game reference. So let's create a member here. Let's call it RNG. And we can probably initiate it right here. So random number generator, part of the game class. It should be static, actually, now that I think of it. No, hang on, we have an instance. It doesn't have to be static. That's fine. We can have it package private. So this means my entity, my star, sorry, can do x equals game dot RNG next int. Of course, I want this value to be anywhere between 0 and the edge of the screen. We have methods of getting the size of the screen, but easier still is to use the dimensions of our frame buffer. Remember, I'm calling set fixed size on my holder here so that my buffer is of a controlled pixel width and height. So let's just make these package private instead of private. And that way we can use them as game settings. Which also reminds me, we should add a to-do here. Move game settings to resources. Well, game settings, configuration settings, whatever. Hard-coded values are a bit silly. You generally want anything that affects gameplay to be in the hands of the designer. So you want to have them somewhere, probably in a configuration file. So you don't have to rebuild the game to test different values, like how much damage should the player's gun do. You want that to be quick to iterate and test on. But right now, quick and dirty, it is. So I want this to be next int game stage width. Same on the y-axis, but stage height. Lastly, we need some velocities. To keep it simple, we'll start with just moving on the x-axis. So velocity x, and I'll hardcode this to something negative so that it moves to the left, because I think the player is going to move left to right. So we do this -4, say. It's a float. We integrate and update, we draw in render, and we have an initial value, and the color is hard-coded. We don't have a width and height yet. That's a problem, right? Right and bottom doesn't work without height and width. So let's do that. Let's do width at, I have no idea. Let's just try something like this. Height is 10, width is 20. So that should give us a rectangle of some kind. We can go back to the game now and create a list of entities. So that's going to be, that should actually be a private member. We don't want anyone to mess with the entity list ever, apart from the game class. So let's create an array list of entity. Come on. Entities. There we go. We want to have another gameplay setting, namely the number of stars. So let's do, I don't know, star count. Let's put that at 40. Some other arbitrary number. And then let's create a loop in our constructor to build them. And make sure, when you start instantiating entities, that the reference to game has been set first, right? Otherwise you will have a null exception on your hands. So for int I equals 0, I is less than star count, I plus, walk from 0 up to star count, creating a new entity and adding it to the entities list, obviously. Entities, add new star. And then we just need to update our update and render methods to make use of it. Like we say here, update all entities. So let's do for each entity E in the entities list, call update. Same thing in render. Render all entities. And that should pretty much be it. Oh yeah, it needs a canvas and a paint object. And if you remember, we have these objects as members in the game class because we do not want to create them every time the renderer is run, which is, as you know, at least 60 frames per second. Why can't I close all of these? So here's our game. We see nothing. Okay. So we call render with entities and paint. The background is black. Our entity is not what I want. I want my star. That should be a fairly bright color. Width, height, draw rect. I'm going to start with just setting a breakpoint in the renderer for our star, the render function rather, to see if that function is called correctly, or called at all rather. And I messed that up, so we restart the debugger. Load, load, load. Right, so the call happens. We have a color. Our position is weird. This is not a value I would expect to see. Ah, no, yes, it is. Okay, so we've run into the first interesting little bug in our game here. The fact that we are running update a lot before we get anything on screen. This happens because in-game, in our render, if we can't acquire and lock the canvas, we immediately bail. So there is no point, we never get to the unlock and post canvas, which means we're not synced to the UI thread, which means our core loop gets to spin as fast as it's want. So the thing we do to fix this is just implement world wrapping. We can do something like if our right edge is below 0, then our object has walked off the left edge of the screen. So if that happens, we want to set our left side to the stage width. That's a static value. So this way, when our object goes off the edge on this way, we put it back over here on the right side, lining up to the left. I hope that makes sense. Let's debug this. Not debug, let's just run it. See what it behaves. Start the game. So there we go. We have a bunch of very small rectangles and they are... well, they're behaving well. Cool. So a thing I wanted to show you here is what I really want these things to be is circles. And if I change these to circles, the drawing code will not initiate from the top left corner, so they will be offset. If we go to the student portal, if you check the coordinates article, you know, oh, I apologize, that a bitmap and most other graphical objects are oriented around their top left corner. That's where X and Y relates to in our entities. But if I were to draw a circle, it would draw around the center point. So we have to offset the drawing to account for that. If I go to game and say remove a bunch of these, let's just do 4 of the stars. And then let's make it draw a circle instead. So canvas, draw a circle. And it will want a position. This is the center and the center. It wants a radius, so let's make that a member. And then it wants paint again. Whoop, leg off. It makes paint. We need a radius member. That should be private. And we can hard code it. I want it to be a random number later, but let's set, I'm being silly now. Let's set radius to 40. And then width, of course, when we're talking about real world objects or anything else logically, width of a circle should be 2 times the radius. So radius times 2, and the same with height. Now if we run this, we should get some teleporting going when we're trying to world wrap. So these objects will pass the screen and they will run for a bit too long, and then they will appear on the other side a bit too late. Because the logic of our left and right, is that right? Oh, whatever. The logic of our members rely on width and height to be correct, and that our coordinate starts from 0, 0 up in the top left corner. So this is ugly and needs to be fixed, and we can probably hack around that if we offset our drawing code slightly. So let's see. This draws with the circle at X. So do I want to remove or add to it the radius? If I want to move it, I want to move the drawing to so that the X is the left side, so then I'd probably want to add the radius. Let's try that. Yeah, that's actually perfect. So now you can see how it gradually comes on instead of teleporting in from the other side. And of course we want to make sure that that's accurate also on the y-axis. So we do velocity y is -4. If velocity on the y-axis is negative, then we're moving upwards. If you remember the coordinate system again, right? 0, 0 is the top left corner. So if you're moving towards 0, you're moving upwards. And let's just try the same here. Add half of the width to our y position when drawing. We have velocity y. That should be enough for us to move in the correct direction. Later on, I probably want these stars to respond to the player. We don't have world wrapping on the y-axis, I just realized. So let's add that as well. If our bottom has passed 0, then we are entirely off screen and we want to appear at the bottom of the screen. So set the top of our sprite at game stage height. That should give us world wrapping in this direction. Start the game. Yeah, so later on, yeah, this looks fine. This is perfect. Later on, I want the stars to respond to the player. So if the player is moving fast, I want the stars to be zooming past quickly. And if the player is moving slowly, the opposite, right? And let's see, the colors are a bit shit. I could make them shittier still by just turning them white. So let's do something just a little bit brighter. The size needs to be randomized, so I can do that. Set radius to, use the random number generator, grab something up to, say that I wanted 8, then I'm gonna take a random number between 0 and 6 and add 2, so that I have minimum value of 2 to 8. And then I'll add a to-do, gameplay setting, move it. This value is hard-coded, it's a magic value, well, both of these values, and so they need to be set somewhere where a designer can reach them. Never hard-code a value in your game. Same thing with this velocity. But like I said, we will have this be set in response to the player's actions later on. So right now we're just going to leave that hard-coded and then create a player, I think. Let me just, before I hang up here, go back to the star count and maybe turn this up. Did I set the size to something reasonable? Yes, I did. Just make sure that this still runs and looks all right. How much time have I spent for you? Oi, 20 minutes, goddamn. So there we go. A purple star field. They are wrapping the world. And it looks all right. You can, of course, randomize their position on the y-axis also. So when you're wrapping on the right here, you could decide to put them at different heights to have even more variety. But I'll leave that as an exercise to the viewer. I'll see you in the next video when we start building the player class.